Hello everyone. In this session, we are going to discuss about IGBTs. So, IGBT is an insulated gate bipolar transistor. So, the IGBT combines best of both the transistor. That is, it combines MOSFET and BJT. The high impedance input impedance of MOSFETs and low conduction loss of BJT. So, it combines both the best both. So, let's make it a simple way. So normally what is an IGBT? So IGBT is an insulated gate bipolar junction transistor. So it has it's a three terminal device, that is gate, collector, emitter. It acts as an electronic switch in high power applications used widely in inverters, motor drives, UPS and other renewable systems. So normally it the structure as well, it combines MOSFET and BJT. So we'll break into the structure. So before, this is the symbol for BJT and this is the structure. So normally we have, as said in the previous video, P plus is nothing but it's a higher, normally P plus is highly doped the P-type material. That is, plus represents highly doped. We have a SiO2 layer, we have a SiO2 layer, a drift layer. This is a thing in power electronic devices, and injection layer. So the MOSFET parts, here the MOSFET, right? It's a combination of MOSFET and BJT. Here the MOSFET part controls the input and the BJT part handles the large current in the input. So gate controls collector emitter current with a little power required to the input. So here we have two modes of operation. If we're going to the modes, we'll just discuss in detail with the structure. So here at the bottom we have a metal layer and we have a p-type substrate, p plus substrate, and we have n minus in a drift layer. So this is your drift layer here. Again we have a p-type material and we have a n plus. Here we have a SiO2 insulated here as well. And this is your emitter, gate and collector. So here we have on state and off state. When we'll be calling the device as in off state here is when we are giving gate emitter voltage. Okay. When the gate emitter voltage is less than your threshold voltage, there will be no conduction occurring between collector and emitter. So it will be acting as an open switch. And in on state, your gate emitter voltage will be greater than your threshold, and here since it's a combination of MOSFET and BJT, MOSFET action triggers the BJT conduction. So the heavy current will be flowing from collector to emitter. So it will be acting as a closed switch. So normally when we are applying a positive voltage to the gate, so that will be a channel which allows a current injection. So this enables the large current to flow from collector to emitter part. So once it's on, it has low conduction loss as in BJT, and it require no gate current after that. So that is BJT is called as voltage controlled bipolar device. So here some of the advantages of BJT are, it's as we discussed in MOSFET, IGBTs also have high input impedance and it has a low on state voltage drop, and it handles high current and voltage, and it has better switching performance. So this is the characteristics of uh, IGBT. So we have VI characteristics as well as transfer characteristics. So the VI characteristics will be plotting between output voltage and output current. Here output current is collector emitter voltage, output current is collector current, and here your gate source voltage will be kept as constant, and this is your active region. Okay, normally this is your active region, and we can vary the different gate source current. So this is your VI characteristics, and we have a transfer characteristics as well, and this is your threshold voltage. Okay, and here we have switching characteristics of IGBT. So the switching characteristics of IGBT is plotted between um, gate emitter voltage. Okay, so this is a gate emitter voltage and current. I mean collector emitter voltage and collector current. So normally see here This is your VCE. Your VCE, what happens? It will be dropping from, you can take it as 100% or maximum to the 90% of it. Okay. That time we'll be calling it as delay time. Okay. And from 90%, it will be, that is zero point 0.9 of VCE to zero point 0.1 of VCE. We'll be calling it as rise time. As well as you can see in the collector current, it will be starting from minimum. Okay, see, this is your collector current characteristics. It will be starting from, in your delay time, it will be starting from minimum till zero point 0.1 of your IC. That is your 10%. And in your rise time, it will be going from zero point 0.1 to 90%. So you can see the switching on, right? This is your T on. Delay and rise time is combination of combining, it will be your on time. So in on time, what happens here is your current starts increasing. That is, it starts to conduct. Your device will be starting to conduct. So that is T on here. And voltage will be dropping somewhat. And your current will be going on till in maximum IC. After a particular time, if you need to switch on, it will not switch on immediately as usual. It will be coming to 0.95 C and it will be coming to zero point 0.1 and it will be reducing. This is how your device, your power electronic device will be switching on. So that's all with the IGBT. So thank you.